I believe this is where we left off, was going through the domain and range specifically of quadratic functions. And so the domain and range of a quadratic function have a little bit to do with what the graph looks like. Okay? If it opens up, then what you're looking for is wherever this vertex is, hk. What you can see here is there's no restrictions on the x's, right? This is going to be whether the graph opens up or down. The domain is always going to be all real numbers, so from negative infinity to positive infinity. But the range is determined by whether the graph is opening up or down. And if the graph opens up, meaning if its leading coefficient is a positive number, then your range begins at the vertex and it extends infinitely in the positive or upward direction. So if you have an a value that's positive, then your range is going to begin at your y-coordinate of the vertex, which is designated by the letter k here, and it extends all the way to infinity. And now, what if your graph instead was one that opened down? Still assuming that you're dealing with the vertex at hk. Okay, so here our domain is still infinity, or is still all real numbers. Okay, that doesn't change at all. Okay, but the range, if you're dealing with a negative leading coefficient where the graph is opening down, now the vertex y-coordinate is the highest maximum point. So it would extend all the way from negative infinity up to that point. And notice in each of these cases, the domain is going to include the vertex. Okay, so it's brackets at the vertex. Okay, now that's if you get the graph, or that's identifying the domain and range if you're starting with the graph. Okay, the other two forms of the equation that you're likely going to see is this vertex form here and this general form here. So when you're looking at the vertex form, okay, the domain and range are easy to find, right? The domain is going to be what? No matter what, it's always going to be all real numbers. Okay, and then here, your range, when you look at this, is going to be exactly what we just found. Okay, so if we're dealing with a positive leading coefficient, it's from k to infinity. If we're dealing with a negative leading coefficient, it's from negative infinity to k. Okay, because we're given the hk values of our vertex, right? Because we need to know our vertex here, and the vertex from this form is hk. That changes when you're given the general form. Okay, in general form here, what we're looking at now is the domain. Still going to be the same, all real numbers, negative infinity to positive infinity. But now when we're identifying the range based on whether the leading coefficient is positive or negative, we have to find the y-coordinate of our vertex. And the y-coordinate of the vertex is a little bit more work to find if you're given general form. Okay? And the way that you can identify the vertex here, again, in general form, the x-coordinate of the vertex is negative b over 2a. And the way that you can find what the corresponding y-coordinate would be is to evaluate this function for negative b over 2a at that point. So this right here is sort of the calculated value of the upper and or lower limit for your range, right? If your leading coefficient is positive, we're going to have a lower value of this function, or this this y-coordinate, and it'll extend all the way to infinity. And if you're dealing with a negative leading coefficient, then you're going to extend from negative infinity all the way to, and again, we're going to evaluate our function at the x-coordinate, negative b over 2a, okay, to get our range. Okay? And so the answers that you're looking for here would be sort of these forms. Okay, again, the domain is always going to be all real numbers. Okay, but a lot depends on what you see. And now, you don't have to memorize these. This isn't about memorizing these relationships. All I'm doing to show you this is to sort of relate how you can find the domain and range. Okay, but you're going to have to make those distinctions based on whatever form you're given.